Start, sir.
Good morning to all of you. This is Mova Prasad signing into DCEB Suryapeta YouTube live channel. And today is the fourth day of secants and tangents. And we are in the exercise 9.2. Sir will discuss about the constructions which are remaining in the exercise 9.2. And after that, the remaining part, which is most important for you in the annual examinations. Pratap Reddy sir, please continue.
Thank you, sir. Good morning, one and all. Okay, children. Yesterday, we learned that how to construct pair of tangents from an outside point of the circle to the given circle. It is general construction for any circle, for any outside point. But in exercise 9.2, there is a problem giving values. The radius is given and the outside point, the distance between the center and external point is given in the problem. For that problem, we are going to construct. The problem is exercise 9.2. Fifth problem, model. Fifth problem, model. Why I am calling this as model problem of number 5? Given that, draw a circle of radius 6 centimeters from a point 10 centimeters away from its center, construct the pair of tangents to the circle and measure their length. Verify by using Pythagoras theorem. R equal to, given that R equal to, radius equal to 6 centimeters, and the distance between the center, if the center is O and the external point is P, the distance, that means OP is given as 10 centimeter. 10 centimeter. Construct the pair of tangents from the point, outside point P to the circle of radius 6 centimeters. But if we take these values, we can construct on the white paper, no problem. It is convenient. If we construct on a white paper with our geometry box. But we are having here a big geometry box and a big compass and big blackboard. Okay. If we take these small values, small radius and a small distance, then it cannot be visible to you clearly. It cannot be visible to you clearly. It is very, very small on the blackboard. The figure becomes very small. That's why I am changing the problem and I am changing the values of radius and the distance between the center and external point. Okay. I am taking radius as 15 centimeters. Just for convenience, I am taking radius as 15 centimeters and the distance between the center and external point as 25 centimeters. 25 centimeters. That means we have to draw a circle of radius 15 centimeters and locate an external point P outside the circle such that OP equal to 25 centimeters. Then we have to construct pair of tangents from P to the given circle. That's the problem. Okay. Okay. For any construction, first, what is the first step? Drawing a rough diagram. Drawing a rough diagram. Okay. Now I am drawing rough diagram for this. Just to look at the blackboard. First, draw a circle of radius 15 centimeters. with center O. The radius is 15 centimeters here to here, 15 centimeters, and locate a point P outside the circle such that OP equal to 25 centimeters, already 15 centimeters here to here, 15 centimeters, extend it to 10 centimeters, or locate a point P here. This is point P such that OP equal to 25 centimeters. Join O and P. Join O and P such that OP equal to 25 centimeters. 25 centimeters. Then, what is the second step? First, we are drawing a circle of given radius 15 centimeters. That means this is 15 centimeters radius. Here to here 15 centimeters. Here to here 25 centimeters. Then, what is the distance between this point of contact and outside point? It will be 25 minus 15. Here 15 centimeters. 25 minus 15, 10 centimeters. This distance will be 10 centimeters. Now, the second step is draw perpendicular bisector of OP. Draw perpendicular bisector. Already we know how to draw perpendicular bisector of a line segment. Taking more than half radius with compass, draw an arc outside above the line segment OP and below the line segment OP. With the same radius from P, intersect the previous arcs, draw another two arcs like this. We have to draw two arcs with the same radius from O and P, above OP and below OP. Just locate intersection point and draw a line through this to the first. Sorry. More than half radius, total 25 centimeters. Means what is the midpoint? Just to guess it. Midpoint means 25 by 2. 12.5. 12.5 means perpendicular bisector will be inside the circle. It intersects the circle. Okay? Right. From taking more than half of the radius, draw an arc here. And again, like this. Draw perpendicular bisector. Then this point will be midpoint. This point will be midpoint. This point will be midpoint. M. Call it as M. Then with center M, taking MO or MP as radius, draw another circle. Draw another circle which intersects the previous circle at two distinct points. Locate them as A and B. This is C1 given circle. This is C2. Now, join P and A and P and B. That's all. Then PA and PB are the required tangents from external point P to the given circle of radius 15 centimeters. That's all. Join OA and OB. That construction will be completed. After that, we have to measure the, it is given that we have to measure the pair of tangents, lengths of tangents. Both are same, PA equal to PB. We have to measure the lengths of tangents, then verify by Pythagoras theorem. Since here this is 90 degrees, this is also 90 degrees. Therefore, we have to verify by Pythagoras theorem. That is the rough diagram. Okay, here one important point is there. If outside point is more than double the distance, more than double the distance. That means if it is more than 30 centimeters, radius is given as 15 centimeters. If outside point, the distance between O and P is greater than 30, Greater than 30 means 35 or 40 centimeters. If it is 40 centimeters, then P will be here. Then what is the midpoint? 20 centimeters. 20 centimeters means perpendicular bisector comes out of the circle, outside the circle. Then perpendicular bisector comes outside the circle. That is important. Next, if double the radius, if OP is if OP equal to double 2 times with radius, twice the radius. That means if it is 30 centimeters, then OP equal to 30 centimeters, then exactly midpoint at 15 centimeters. That means on the boundary of the circle, on the boundary of the circle. Then perpendicular bisector will be like this, and it will touch the given circle. It will touch the given circle. It is also a tangent, but no need to consider here. Only we have to draw pair of tangents from P. That is important. Okay. If the point P less than twice the radius, that means 2 into 15 twice means 30 centimeters. Already here given that 25 centimeters, less than twice the distance, radius, twice the less than radius. That means 25 centimeters less than. Then perpendicular bisector will come inside the circle, somewhere inside the circle. Since midpoint from O to 12.5, from P to also 12.5 centimeters. That's why it will intersect the circle at 2 distinct points. Right. Now we are going to construct fairly. Okay. As per rough diagram, first we have to draw a circle of radius 15 centimeters. I am taking 15 centimeters. One side inches on the ruler, one side inches are identified, and another side centimeters are identified. 15 centimeters. I am taking 15 centimeters. This is 15, 0 to 15 centimeters. I am drawing a circle. Okay. Is center O. Is center O. I have drawn a circle of radius 15 centimeters. Now we can take a point on the circle. It will be 15 centimeters. Okay. Now, next we have to locate the external point P. Given that OP equal to 25 centimeters, just with the ruler, we are marking. Hold 0 at O point. (25 centimeters). Okay, here it is 25 centimeters. Just locate the point P here. Since it is 25 centimeters from O, this is P point. Now join O and P. Now join O and P. That's all. This is the point O. This is the point P. External point P to the given circle. Next, now what to do? We have to construct perpendicular bisector. Okay, perpendicular bisector of what? OP. By taking more than half of the distance OP. This is more than half of the distance. Okay, draw an arc above OP and below OP. From O with the same radius from P. Also, we are drawing two arcs above AP and below AP Okay, we have drawn two arcs from O and P with the same radius. First, locate intersection point of two arcs like this. Join these 2 points by ruler. Okay, say XY, the line XY. We are drawing perpendicular bisector of OP, already drawn. Intersection point of this line and OP will be the midpoint of OP, perpendicular bisector. It is dividing OP into two equal parts. Already OP is the distance 25 centimeters. That means comes under 12.5 centimeters. Just this as M. Just measure and confirm. If we measure, it will be 12.5 and 12.5. Okay. Name the midpoint as M. Then with center M. Now we are drawing another circle. As in rough diagram, C2. This is C1. Given circle C1. Now we have to draw C2 with center M and taking radius as MO or MP. Both are same. Okay, adjust here. This is C2. This is C2. Okay. With center M, taking radius as MO or MP, draw another circle. C2. Now, locate intersection points of both the circles. Here and here. These are the two intersection points. Name them as A and B. Next, join P and A. Also join P and B, which are the required pair of tangents from P to the given circle. Few students are doing mistakes. Joining P and this point. Already you have done arcs for perpendicular bisector. Don't join these points to P. Okay, those are not tangents. Those are not touching the circle. That's why I'm saying join P and A only. P and B. That's all. Those are the required tangents. Okay. These two are the pair of tangents, PA and PB are the required tangents. Now join OA, radius. Next join OB, this is also radius. That's all. Construction completed. Now, first step is over for construction. Now, second part is there. That is, measure the two tangents, lengths of tangents. Now, I am measuring two tangents, both are equivalent. Already we have proved. We are measuring. This is 25 centimeters, OP 25 centimeters, and OA is 15 centimeters, radius, OB is also 15 centimeters. Now, I am measuring the distance between A and P, that is exactly 20 centimeters, 0 to 20, 0 to 20 here, 0 to 20. This will be 20 centimeters. This is also OB, PB is also. I am measuring distance between P and B. It is also exactly 20. That means by measuring two tangents, we are getting PA equal to 20 centimeters equal to PB. This is the second part of the problem. Measure the two tangents, means we are getting the length of the tangents as 20 centimeters. Next, both are equivalent. Next, third step, third part of the problem. What is asking? Verify by using Pythagoras theorem. Okay, now we have to verify by Pythagoras theorem these pair of tangents having length 20 or not. Okay, here the tangent is perpendicular to the radius through point of contact. That's why I am putting perpendicular symbol here. Here also perpendicular 90 degrees. Okay. Both are already we know these two are congruent triangles, right angle triangles by RHS congruence. Okay. Now taking triangle OAP, right triangle OAP. Consider right triangle OAP. Okay. In any right triangle, by Pythagoras theorem, what Pythagoras theorem says? Square of the hypotenuse is equal to sum of the squares of other two sides. What is the hypotenuse here? OP. In right triangle OAP, 90 degrees is at A. These two are sides having 90 right angle. Other side OP will be the hypotenuse. OP will be the hypotenuse. Therefore, by Pythagoras theorem, square of the hypotenuse, that is OP, square equal to square of the sum of the squares of other two sides. What are other two sides? OA and PA. That means OA square sum plus PA square. Now, already OP and OA are given. Like this is OA, this is equivalent to OA and OB also. OA and OB. Already OP equal to 25 centimeters. OA equal to 15 centimeters radius and OP equal to 25 centimeters. Substituting these values in this equation, OP means 25 centimeters, substituting 25 square, and substituting value of OA, that is 15 centimeters, 15 square, plus now we have to find length of the tangent PA. Now we have to find the length of the tangent PA, that is the variable here. These two are constants, this is the variable to find. Okay. Now, what is the square of 25? 25 to 25, already we know the value, it is 625. And The square of 15. 15 into 15. We know 225 plus PA square. Okay. Now transpose 225. The term 225 on right side, transpose it to left side. Plus 225 becomes minus 225. If we transpose one term from one side to another side, the sign will be changing. If it is positive, it becomes negative. If it is negative, it becomes positive. Here it is positive, 225. It becomes negative. That means minus 225. After transposition, here PA square. We have PA square. Now subtract 225 from 625. What we get? It is 400. It is 400 equal to PA square. PA square. Okay. Now taking square on right side, transposing square on right side to left side, it becomes square root. There is a relation between square and square root. If we transpose one of the square or square root becomes square becomes square root. For example, if we have x square equal to 4, x square equal to 4. If we transpose 2, means if reciprocal, we have to write reciprocal of the power. If power transposed to another side, x equal to 4 power 1 by 2. Here it is 2 by 1. 2 by 1 becomes 1 by 2. Since 1 by 2 is the reciprocal of 2 or multiplicative inverse. Okay, right. 1 by 2 means square root. 4 power 1 by 2 means square root of 4. X equal to root 4. That means if square transposed to another side, it becomes square root. If square root transposed to another side, it becomes square. That's why here also we are transposing square to left side. That means we are writing plus or minus square root equal to PA. Don't write again square. Already square is transposed to left side. It becomes square root. Only PA is there. That you have to remember. Don't write square again. Next, for any square root value, there are two values. One is positive and another is minus. Just put plus or minus. Everywhere you have to write first. If you apply square root, write plus or minus. Plus value is called principal square root value. If two are needed, we can take two values, or one is needed, only one can take. Okay, right. Plus or minus square root of 100 means 400 means just we are writing simply what is the square root of 4? It is 2. Already we know 2 square equal to 4. Next, if two zeros are there, now we have to write only one zero for square root value. If two zeros, then we have to write 0. If 4 zeros, 2 zeros to write. 6 zeros, 3 zeros to write. Even number of zeros are there, then only we can write like that. Otherwise, we can say square of the 20 is 400. Square of the 20, 20 into 20. 20 into 20 equal to 400. 20 into 20 equal to 400. That's why square root of 400 equal to 20. Again, equal to PA. Right. Now, PA equal to 1 is plus 20, another value is minus 20. What to take? Which value is important here? Already, these are the sides. These are the sides of the triangle. Sides means distance. Distance. Length means distance. Distance is always non-negative. Distance is always non-negative. Means it must be positive or 0. It must be positive or 0. That's why we can neglect the negative value. Therefore, PA equal to, we have to take only positive value, that is 20 centimeters. Only positive value will be taken. Minus 20 value is neglected since distance cannot be negative. That's the reason. Therefore, we are getting PA equal to 20 centimeters. In the same way, similarly, we get PB equal to 20 centimeters. In the same way, because these two are congruent angles, corresponding parts are same, corresponding part CPCT. Okay, PA equal to PB. We are getting PA, then automatically PB is the same value of PA. That's all. This is 20. We are getting 20 centimeters. Already by measuring, we are getting 20 centimeters. By measuring also, we got 20 centimeters. By verification also, we got 20 centimeters. Coincide. In both the methods, the length of tangents are same. That is the verification. Over. The problem is over. Just note down. Okay. After this, if 4 marks is given in examination, 1 mark for rough diagram, 2 marks for fair construction. This is the fair construction. Write as fair construction. Fair construction. And one more point is there, that is steps of construction. I will explain steps of construction. Just note down. 1 mark will be given for steps of construction. 1 mark to 1.5 marks. Okay. Now steps of construction. Just note down. First step. What is the first step? First, draw a circle of radius 15 centimeters. Draw a circle of radius 15 centimeters with center O. With center O, and locate a point P and locate a point P outside it. This is the first step. Draw a circle of radius 15 centimeters with center O and locate a point P outside it such that already OP is given. OP equal to 25 centimeters. 25 centimeters. Already distance is given. That's why locate a point P outside it such that OP equal to 25 centimeters. This is the first step. Second step of construction. Then join O and P. Join O and P and draw perpendicular bisector. And draw perpendicular bisector of OP, the distance OP. Join O and P and draw perpendicular bisector. No need of procedure, just write, draw perpendicular bisector of OP and locate midpoint of OP. Midpoint of OP as M as M. Okay, join OP and draw perpendicular bisector and locate the midpoint as M. As M. That is the second step. Now third step. Going to third step. With center M. With center M. MO or NP as radius. With center M and radius as MO or MP, both are same. With center M and radius as MO or MP, draw another circle. Draw another circle which intersects given circle, which intersects given circle means C1 in two distinct points. In two distinct points. With center M and radius, taking radius and taking radius and taking radius as MO or MP, draw another circle which intersects given circle in two distinct points. In two distinct points. Locate them as A and B. Locate them as A and B. A and B. These 2 points. Next, fourth step. This is the last step. Now, already AB are located, intersection points of both the circles. These are the point of contacts. These are the point of contacts. Now, join P comma A and P comma B. Join P comma A and P comma B. Therefore, PA and PB are the required pair of tangents. Pair of tangents from the given point P to the given circle. From the given point to P, external point P to the given circle. These are the steps of construction. Again, I am ready. First, draw a circle of radius 15 centimeters with center O and locate a point P outside it such that OP equal to 25 centimeters. Second step, join O and P and draw perpendicular bisector of OP and locate midpoint of OP as M. Third step, with center M taking radius as MO or MP, draw another circle which intersects the previous circle or given circle in two distinct points. Locate them as A and B. Locate them as A and B. Now, last step, join P and A, also join P and B. PA, PB, therefore P and PB are the required pair of tangents from the given point, external point P to the given circle. These are the steps of construction. Okay, construction is over. Next, we can solve remaining problems of 9.2 exercise after learning statements given in the textbook. We have 4 statements given in the textbook. Those are very, very important for exercise 9.2 and 9.3. Most important statements. Okay, now, what is a statement? We are saying that 4 statements are given in the textbook. Now we have to prove all the 4 statements. But what is a statement? A statement means a sentence which is either true or false. Statement is a sentence which is either true or false. Then it is a statement. It is a sentence. Basically, it is a sentence. There are so many sentences. For example, in mathematics, we have a sentence in any triangle. In any triangle, the sum of the interior angles is 180 degrees. Simply note the point. The sentence, in any triangle, the sum of the interior angles is 180 degrees. Already we know for any triangle, we have 3 interior angles for any triangle ABC, for example. Then angle A plus angle B plus angle C. These are the sum of the all interior angles equal to 180. This is true or false? We know already. Yes, you are right. This is true. This is a true sentence. That's why this is a statement. That's why this is a statement. Again, another sentence is there. In a triangle, this is first one. This is true. This is true. That's why the sentence becomes a statement. Now, in a triangle, there exists 2 right angles. This is also a mathematical sentence. Okay, in a triangle, there exists 2 right angles. Is it true? You can take any equitangled or obtusangled, right angled, whatever the triangle. If there exists 2 right angles, what happens? 90 degrees plus 90 degrees. 2 right angles means this much equal to 180 degrees. Already sum of 2 angles equal to 180 degrees. What about the third angle? There is no third angle. 0 degrees. Is 0 degrees exist in a triangle? No. We say no. That's why there does not exist 2 right angles in a triangle. In any triangle, there does not exist 2 right angles at a time. Okay? Only one right angle will be there for any triangle. If it is 90 degrees, then it will call as a right angle triangle. Okay? Then other 2 angles becomes acute. That means less than 90 degrees. Less than 90 degrees. If this, for example, if this is 90 degrees, then sum of these 2 angles will be 90 degrees. Sum of these 2 angles will be 90 degrees. Means every angle must be less than 90 degrees. Must be less than 90 degrees. Cannot be 90 degrees. Any of the 2 angles cannot be 90 degrees. Therefore, only one right angle exists in a triangle is possible. That's all. That's why. What about this sentence? Is it true or false? Okay, definitely it is false. It is false. This is also a sentence saying false. False sentence. Therefore, it is also a statement. It becomes a statement. No doubt. It is also a statement. This is also a statement. That means a sentence which is either true or false is a statement. There are some sentences which are neither true nor false. Neither true nor false. Say one like that one sentence which is neither true nor false. Our Indian cricket team will win next World Cup. Will win next World Cup. Is it true or false? Our Indian cricket team will win next World Cup. Next means 2021, 22, 23, wherever. Will win the next World Cup. Means, how can you say our team will win? No doubt. It is an indefinite. Indefinite. Okay, it is not definite. They can participate or cannot participate. If participated, if the team will be participated, then we can win or lose. We can win or lose. Both are possible. We can't say we can win the World Cup or we can't win the World Cup. We can't say definitely we can win the World Cup or we can't win the World Cup. It is indefinite sentence. That's why it is not a statement. It is not a statement. Okay. Okay, first statement. I am reading first statement. Statement 1. Just to look into the textbook. I am not writing the statement, but we can discuss and prove the statement. The center of a circle lies on the bisector of the angle between two tangents drawn from a point outside it. Drawn from a point outside it. Okay. Now first draw a circle. Draw a circle with center O and locate a point P outside the circle. Point of contact. Locate the point of contact. Just join the here it is A and B. Join radius OA and also radius OB. Join OP. Join OP. That's all. Here it is 90 degrees. Here also is 90 degrees. Tangent perpendicular to the radius through point of contact. Okay. Now, what is the statement? The center of a circle. The center of a circle lies on the bisector. Bisector of the angle between two tangents. What is the angle between two tangents? So this is the angle between two tangents. Two tangents are PA and PB. PA and PB are two tangents. Angle between means angle APB. Angle APB. Drawn from a point outside it. Okay. Now we are proving the statement. The center, that means O, lies on the bisector of the angle between two tangents. Now we have to prove first this OP is the bisector. Bisector of what? The angle. Bisector of the angle between two tangents. Between these two tangents. Okay. That means it equally divides the angle into two parts. Now, what happens? There exist two right triangles. One is OAP, triangle OAP, and a triangle OBP are two right triangles. Right angled triangles. Right triangles. Okay. These two are two right triangles. Now, already we know that those two are congruent. Again, we are proving OA equal to, this is radius, this is radius, OA equal to OP, OB equal to radius. Next, OP equal to OP, common hypotenuse, common hypotenuse. Okay, in these two triangles, these two are equivalent, and OP is the hypotenuse of this triangle, also hypotenuse of the below triangle. Therefore, OP is the common triangle. These two are equivalent. Again, this is equivalent to itself, OP. Next, from RHS property, congruence rule, we can say that triangle OAP congruent to triangle OBP by RHS congruence rule. Congruence rule. A pair of sides are equivalent. Their corresponding hypotenuses are equivalent. That's why these two are congruent triangles. Then by CPCT, corresponding parts of congruent triangles are equal. Already we have proved the remaining corresponding sides, PA equal to PB. Already we have written in the previous classes. Already we proved PA equal to PB. Okay. Here this is no need, but I am writing PA equal to PB by CPCT. Now, what about angles? This corresponding angle, these two are corresponding angles, are equivalent. These two are corresponding angles. Okay, these two are corresponding angles. By CPCT, these two are also equivalent. Again, these two are corresponding angles. These two are corresponding angles. That means angle APO. Angle APO equal to angle BPO. Angle BPO by CPCT. By CPCT. Corresponding parts of congruent triangles are equal. That's why this angle is equivalent to this angle. These two are equivalent angles. That means OP is the, then OP will be acts as a right bisector of the angle APB. Therefore, OP is the bisector of angle APB. Angle APB. That's all. OP is the bisector of angle APB. This is bisecting this angle into two equal halves. Two equal halves. Two equal angles. That's all. That means OP, whenever OP is the bisector of this angle between two tangents, then O lies on the center, lies on the OP. Center lies on the OP. That's all. Therefore, O lies on OP. Proof is over. That means center of the circle lies on the bisector of the angle between two tangents. This is the first statement. We have proved the first statement as true. In the same way, we have to prove the remaining three statements. Okay, note down. Statement 2. Processor, time unda sir? Processor. ఇంకొక స్టేట్మెంట్ చెప్తా సార్. స్టేట్మెంట్ 2.
5 minutes ఉన్నా సార్.
5 minutes లో అయిపోతుంది సార్. ఓకే. Statement 2. In two concentric circles, the chord of the bigger circle that touches the smaller circle is bisected at the point of contact with the smaller circle. For this purpose, first draw two concentric circles. two concentric circles. Concentric circles means having same center but different radii. Both are having same center O, but different radii. The radii are different. Okay, now take a card of bigger circle. Take a card of bigger circle. AB, endpoints, locate the endpoints of the card of the bigger circle as AB. The first bigger circle, name them as C1 and the smaller circle as C2. C1 and C2 are given. Those two are concentric circles, means having same center with different radii. Okay. Take a card of bigger circle which is a tangent to the smaller circle, which touches the small. He says which touches the smaller circle. Means the card of the bigger circle touching the smaller circle at only one point. We can say it as P. Okay. Join OP, OA, and OB. Join these OA, OB, and OP. This is the smaller radius. This is the capital radius. And the radius of the bigger circle, these two are the OA equal to OB, let, and OP equal to radius of the smaller circle. Okay. Now, we have to it is bisected. The touches the small circle is bisected at the point of contact. Okay. This card is, now we have to prove the card AB. AB is a card. AB is a card of the bigger circle. Is a card of C2 of the circle. C2 of the circle. C1, sorry. Of the circle, bigger circle, C1. Now, it can be bisected. It can be bisected at the point of contact. It can be bisected at the point of contact. That means P, now we have to prove P will bisect the card AB into two equal halves. Into two equal halves. That means we have to prove PA equal to PB. PA equal to PB. If we prove PA equal to PB, then the card must be bisected by the point of contact. That's all. That means radius through the center. Radius through the point of contact is bisected the card AB. Now, these two are right angles. Already we know. Okay, these two are right angles. For example, in OAP, equal to PB. Okay, now these two are right angle triangles. Again, by RHS property, OA equal to OB. Triangles OAP and triangle OBP. Consider these two triangles, right angle triangles. Already, angle OPA equal to 90 degrees. These two are 90 degrees. Got right angle triangles, right angled. OA equal to OB, one pair of sides are equal. Since OA and OB are the radius of the bigger C1, therefore those are equivalent and one pair of sides are equivalent in two triangles. Next, this is the common side. This is the common side. OP equal to OP, common side. Common side of both the circles. OP is the side of triangle OAP and is also a side of OBP. Therefore, OP equal to OP. Right? Right. Okay. Now, here, one common side means one corresponding sides are equal. OA and OB are hypotenuse. Just see. OA is the hypotenuse of this circle. OB is also hypotenuse of the second circle. Therefore, these two are corresponding hypotenuse. Those are equivalent. Okay, one pair of sides are equivalent. Here, one pair of sides are equal. Here, the pair of hypotenuses are equal. Hypotenuses are equal. Corresponding sides and the hypotenuses are equal. Therefore, we can say right triangles OAP is congruent to triangle OBP. Therefore, two right angles are congruent by RHS property. By RHS property, congruence rule. Okay. Then CPCT, we can apply CPCT. Corresponding parts of congruent triangles are equal. What are the corresponding parts? Already OA equal to OB, two hypotenuse are equal, one common side, OT equal to OP. Next, what are the remaining sides, corresponding sides? For this triangle, PA is one side, third side. And for the second triangle, PB is the other side. These two are the corresponding sides. Therefore, PA equal to PB. PA equal to PB by CPCT. By CPCT. Corresponding parts. These two are the corresponding parts. Therefore, they are equivalent. By congruence. By congruence. Those two are congruent triangles. Therefore, all the three pairs of corresponding sides are equivalent. Already two pairs are equivalent. Now, we have proved the third pair, PA and PB are equivalent. Okay, the distances are equivalent. PA equal to PB. That means P divides chord AB into two equal halves. That is bisected. That means the point of contact P bisected the chord of the bigger circle. Okay, this is the statement 2. It is true. In next class, we can prove the remaining two statements and go to the exercise 9.2 of remaining problem. Okay. Thank you, sir. Class is over, sir. Prasad, sir.
Thank you very much, sir. Pratap Reddy, sir. You have discussed about the construction part and the exercise 9.2 almost all completed. Just remaining two statements is in continuation will be in the next day's class. Thank you very much, sir. Thank you for the technical team who supported for the online classes. See you tomorrow at 9 o'clock. This is Mova Prasad signing out from.
Sir, Prasad, sir.
Sir.
Prasad, sir. Oka nimisham, sir.